So now we have the 16th question, which is a charged particle, mass m and charge q, moves along x-axis with a velocity v0. When it passes through the origin, it enters a region having uniform electric field, the E is equal to minus E j cap, which extends up to x is equal to d. Equation of path of electron in the region x is greater than d is, and we have to choose from the four options given to us. Let's move to the solution. Now this is the second part, which is the answer, and from the figure given to us we take this trajectory and mark that angle theta, and the distance between x and the trajectory is y. So minus of y is equal to half a t square. We have minus y is equal to half qe upon mt square and mark it as our first equation, and x is equal to v naught t. Now calculating the value of t, we have x upon v naught and mark it as our second equation. Now for x is less than equal to d, we have y is equal to minus half of qe upon m into x square upon v naught square. This is the third equation. Now we calculate the slope, that is m, that is tan theta, is equal to minus qed upon m v naught square. Equation of straight line is y is equal to mx plus c, and since we know that m is equal to tan theta, we have y is equal to tan theta x plus c and mark it as our fourth equation. Now we put the value of tan theta in this. We have y is equal to minus qed upon m v naught square x plus c. Now for c at x is equal to d, y is equal to minus qed square upon 2 m v naught square. Now we put this value in the fourth equation. That gives us y is equal to mx plus c. And so we calculate the value of c, which is qed square upon 2 m v naught square. For x is greater than d, as no e, y is equal to minus of qed upon m v naught square x plus qed square upon 2 m v naught square. So we have the value of y is equal to qed upon m v naught square into dy2 minus x. This is our answer.